南オーストラリア州のロックダウンがありました。
Friction occurs.
南オーストラリア州のロックダウンがありました。それが3日間で終わったことは州政府の英断のおかげですが、長引いていたら大変なことです。
It lasted only 3 days thanks to the decision of the government, but if it prolonged, that would have a bigger issue. And there was a problem with the quarantine hotel. If one of our team used its team, we would have more problem. And the possibility was 1/3, but luckily we didn't have to go through that. And also that after we reached Umera, the highest temperature is 46 degrees for installation. And at night, due to a typhoon or a storm, some damage was damaged. And for some side, we had to drive more than 3 hours on a very rough road and to install the equipment. And some team had trouble because they haven't received the equipment soon. But every team has finished what they have to do. And we did rehearsal, and we have identified the possible problem. That we think that we have done whatever we can do. And we received a lot of support from many people, and we understand without that support we can't do that. But we are proud that we have finished what we should do. Every member thinks that they are all indispensable member for the success of the recovery. And I believe that capsule will be brought to the headquarters tomorrow morning. Hello, good night. And this is a live distribution of Hayabusa2 capsule return. And we are from the JAXA Sagamihara campus, the special studio. Today we are going to finish at 3:10, but depending on the situation, we may continue up until 3:30. Now we received a comment from Mr. Fujimoto in Australia, and we will receive another report from Mr. Fujimoto whenever new news has arrived. From now, I would like to introduce today's presenters. Mr. Okawa, who is in charge of outreach. Good night, good evening. My name is Takuya Okawa. I'm in charge of PR at ISIS. So now let me talk a little bit about a story 10 years ago about the Hayabusa1. This is a photo of re-entry of a capsule of Hayabusa1. So I was one of the members of the astronaut. I was in Australia. And this is a photo of a fireball. And I was in the Cooper Valley, and I think some of you have already seen this photo. And you can see this is a track of the Hayabusa main body. And also you can see 2 lines. The thinner line is a capsule track. And the thinner line, the capsule, ends to the end. Even after the main body finished, and finally the capsule was recovered safely. Today, the re-entry of the atmosphere. Today, only a capsule re-enters the atmosphere. And I would like to show you another photo. And this is also for Hayabusa1. And here, the capsule is separated from the explorer. And the explorer is like chasing the capsule, and it disappeared. And it's... However, the Hayabusa explorer will not enter the atmosphere. So today, only the capsule is coming back, and we can see only the capsule. And it seems that the brightness is different between capsule and the explorer. And the capsule was, the magnitude was -4 10 years ago. But today, I would like to see and monitor the image we can see. Thank you. Next, Mr. Hiroshi Imamura, who is in charge of system and impactor. Yeah, my name is Imamura. This is a miniature of the impactor. This is explosives. And this is made of copper. And I was engaged from launch and initial operation. And next presenter is Mr. Isana Kashiwai. I am a science writer and web engineer. I'm writing articles as a writer, and I'm working on website of Hayabusa2. So I am designing something, the banner on the website. And also today's, you can see a countdown script. Actually, this was built by me. And you can see some number. This is the time before until the re-entry. So if it's counting down to 0, then if this is 0, you can see a fireball.
And another one is real-time 3D screen will be shown. That is, I'm making, and already Hayabusa has entered the shadow of the Earth, and actually the sunshine will not hit Hayabusa anymore. Therefore, I'd like to look forward to seeing the re-entry of the capsule only. And for me, actually, I am science communicator Yuko Okayama, and please enjoy this live distribution up to the end of this program. And actually, Mr. Hosoda supervisor is in the control room, but now we are joined in the studio. Mr. Hosoda. Well, actually, I'm the supervisor of Hayabusa project. So that, and already I have finished the supervisor, and now I am one of the project member of this Hayabusa2 project. And after that, I will go back to the control room and I will keep working as one of the operation member. Thank you very much. And actually, as for this project, this is not only in Japanese, but the simultaneously interpreted English version is also provided, and also this live subtitles were suggested by Ms. Hasegawa, who is herself hearing impaired and is in charge of the substation staff and Hayabusa2 ground station, and this was made possible by the cooperation of summary writing group Momiji, and actually it was quite impressive. The Hayabusa1 came back to Japan, and we celebrated the return of Hayabusa with cakes and lots of flower bouquet, and also with lots of smiles. This was 10 years before, however, still everybody remembers that. Today will be the special day for many of us, and let's cheer it. Cheer Hayabusa, have a great voyage. And also, I'd like to extend my sincere gratitude to the member of Momiji. Anyway, Hayabusa project have been supported so many people. And let's pay attention to the Australia. Ms. Shirai, please. Ms. Shirai-san in Umera. Hello, this is Mr. Shirai. Can you hear my voice? Yes? Please let us know the condition there. Currently, actually, you know, the sky, in the sky there are lots of stars in the sky, and we are so much relieved to see the sky, and we have been expecting a lot regarding the weather. We have been very much worried, but since I came into the Umela, you know, we have been paying attention to the weather forecast so much. However, yesterday morning, you know, actually it was raining. However, right before that event, you know, everybody is believing that this is now we are having the best weather since we came here. And actually, you know, even the weather did not betray us, did not betray our efforts. And actually, we'd like to show the great shoot of Hayabusa2. And anyway, we are waiting for it. Come on, Hayabusa capsule. Come on. Anyway, we are feeling so. Thank you very much. I have been believing that, you know, the desert should have always good weather. However, miraculously, we are having a very good weather. So I'm so much happy to hear that. Then I'm so much expecting. Thank you. Well, you said that there are lots of stars in the star, but there is no light in the town, therefore you can see so many stars. Yes, there are so many stars, and even moon is shining very brightly. Actually, I never knew that, you know, the moon can be so bright. Today in Sagamihara, actually, it was cloudy for a long time, but at night, you know, actually, now we can see the stars and even moon. We are seeing the same moon, right? We are sharing the same moon. Yes, that's right. Actually, as advised by Mr. Okawa, you know, the moon can be such bright. Yes, this is Okawa, and you know, actually, we can see many stars. Well, it's quite, you know, impressed because you have a great weather that, and can you see Milky Way visually? Yes. Right before the moon comes out, we could see it very clearly. However, now because, you know, the moonlight is too strong, therefore we can't see Milky Way very well. Oh, I see. You know, the moon is too shiny, right? Is that right? That's why you cannot see the stars very much. Oh, I see. That's right. However, we believe that, you know, the capsule can be seen very clearly. Yes, we will expect that. And lastly, how about the wind? In the daytime, you know, we heard that it's a bit windy. Well, it's not very strong. Oh, I see. Well, it seems the condition to welcome the capsule is kind of perfect. Yes, everything is perfect to welcome the capsule. Okay, let's go back to the studio, and we'd like to have some talk about operation, and also let's review the separation of the capsule. Mr. Imamura, please.
Yes, this is a miniature mark, and this is presented by Nihon Koki. Thank you very much. Now, we would like to review what we did today. During daytime, we did the capsule separation, and the Hayabusa2 escaped the Earth. To do that, we did the trajectory correction, and the capsule is now under the shadow. That means the Hayabusa2 is the shadow of the Earth when viewed from the sun. So, since there is no solar light, so it is moving based on the battery. And in the daytime, Hayabusa2 finished taking pictures, and the capsule already entered. We are going to show you the entry of the capsule and the fireball. And this is a sequence. Hayabusa is heading to the Earth, the change altitude, capsule separates, and it's escaping. It's now grazing the Earth. So we have finished so far. And this is how the capsule is.
ここでですね、一つ紹介させていただきたいなと思うんですが、京都大学の岡山天文台
This Okayama,
望遠鏡でですね、
the telescope at Okayama,
と本体
and actually this is a video of the separation of the explorer and the capsule.
はい、これがその生命望遠鏡で捉えた映像ですね。
And this is the image of the telescope. The center is a capsule, and the left side is the explorer. It may be hard to see. So next one is a movie.
はい、ここにカプセルはずっと
Yeah, here this is a capsule, and this is the explorer is moving away. The capsule is still at the center,
で、
and you can see the Hayabusa is moving away, and the speed is 20 centimeters per second, relatively. And that means we were able to capture this from the ground. And also from the National Astronomical Observatories, they say that they had take pictures and movies. And can you go back to the slide again?
にしたカプセルは、このようなものですね。
And the capsule is like this.
今この形で、回転しながら
The capsule is now flying in this state. It's rotating. It's one rotation per second. And it contains sample container. And the size is 40 centimeter in diameter and 20 centimeter in height and 16 kilogram.
これが分離して、
And this is separated. And this is separated to the back heat seat instrument module with parachute. And this is separated into 3 parts, and 3 landed independently. And the sequence of landing is shown in these illustrations. And now this is spinning once in every 3 seconds, and it has already been separated. And the Hayabusa2 has already evacuated, and the maneuver finished, and it will now re-enter the atmosphere at about 160 kilometers, and the speed is 11.6 meters per hour, and the density of the air increases, so that friction occurs and aerodynamic heating occurs. So the speed is decreased and to almost the same as the speed of the sound. It's around 340, and impact wave. And it gets motion gets unstable,
そこをこの姿勢のまま乗り切り
and it is continued this posture.
0.1km
And when the speed go down to 0.1, then heat shield is separated at this point.
をもうリミッ
And it's separated into 3 parts, as I explained before.
真ん中のところですね。
At the center portion, this is an instrumental module that including container, parachute deployed, and it starts descending. And altitude is 10 kilometer.
この後風の影響を
And after parachute deploys, it's affected by wind.
開いた段階でここの下に
So
あるこの出ている
when the parachute deploys, this is beacon antenna. So the beacon transmits a signal. And the ground station receives it, then it can identify the direction. And the helicopter uses this information from this beacon. And in case there is no beacon signal, and there is something on the parachute which reflects the radar beam. The MARI radar emits radar beam, and it reflects, and we can identify the distance.
インストゥルメントモジュールが地面に着地
And when the instrument modules landed, and still beacon transmits signal, not continuously but intermittently.
間欠的に出すという形をしております。はい。で、あと風で飛ばされないようにこのパラシュート
And the parachute will be detached after it's landed to avoid the capsule is moving. And this is the time and altitude of the sequence. And at 228,
もうすぐですね。
and
はい。
it will be very soon.
下級フェーズになります。
So we can see a fireball phase. So the altitude
下がります。
down from 120 to 10 kilometers. It takes only 3 to 5 minutes. And at 10 kilometers parachute deploys, it takes another 15 to 25 minutes. And it is going to land Woomera area in the southern Australia. And we use various methods to identify the location. And this is the expected landing area. So TCM3, after TCM3, the area is
の中に
150 kilometer to 100 kilometer. That this is a ellipse, expected area. You can see surrounded by blue line. So the capsule is expected to land here.
では管制室の方にちょっと振りたい。
Let's go to the control room in Sagamihara. Okay, this is Hosoda, and let me report the status of the control room as for the Hayabusa2. Currently, actually, at 1:56, it's entered the shadow parts of the Earth, and from that, for the time being, we cannot see the explorer, and now, the atmosphere in this control room is a bit, nervous. Thank you very much. Now, actually, there is nothing that we can do for the Hayabusa2, so everybody is paying attention to the fireball. Even in the control room, everybody is kind of ready to see the fireball. Yes, that's right. Mr. Hosoda, thank you very much. Well, it seems the capsule will re-enter the Earth's atmosphere, and from Australia, Cuba, Perry, we will have the live distribution. Now we can see here, for the time being, until the fireball comes, we would like to have some report in Australia. Well, actually now we are seeing the night sky, and we can see some stars. I'm checking, even the screen of the smartphone, and maybe you can see, the 3 stars. When you see, the brightness of the star is a bit different. Actually, this is a wide-range camera, and this is probably the first level star, and this camera is showing the first grade star. It means that if the fireball's level exceed this level, it should be easy to identify it. Well, how about the brightness of the fireball? Well, actually, it will change gradually. That's really depending on the temperature of the fireball, and also depending on the distance, it should be different. And according to the calculation, from the observation point in Cooper Payne, from -7 to -9 magnitude, therefore it should be brighter than these 3 stars. Incidentally, these stars on the sky are from this angle, probably the brightest one should be Sirius. The feature can be seen even from Japan, yes. When actually it should be the brightest star, even from Sagamihara. This is a fixed star, and this is -1.5 magnitude. Therefore, fireball should be much brighter. According to Mr. Shirai, moon is very bright. Therefore, bright moon and another very bright fireball can be seen in the sky. Well, actually, we are not catching the images of the moon, therefore it's out of the range of the camera. Actually, today's moon's brightness is 20.5 magnitude, and now actually this moon is not this area. Actually, this. We are seeing the anyway Sirius and Orion, and also Epitanus, which is not really easy to see from Japan. Now, the countdown was set to 0. Okay, let's pay attention to it. If it comes from which side? If we see from Kupapeti, it should come from northwest. Okay, it's coming from right side, and it's getting brighter and brighter, and the speed is very, very big, and it is coming through near the zenith. Okay, it has gone. No more lights in the sky. Anyway, re-entry was made. We do like to start the initial analysis. That is a kind of procedures. And are there any movements in Australia? First, hello, this is Fujimoto in Australia. I'm Fujimoto of Umela. The sound is not very clear, but still we can hear you. Please speak slowly. Actually, we traced the trajectory of the capsule by DFS, and now we will start the calculation of the landed place. Thank you very much. DSS is a detection finding system, and actually this is the kind of a system using the beacon signal, and the signal was received. It means that probably the landed position will be calculated, and when the beacon signal was received, there are several lines, and the close point shows that instrumental module should be located there. Therefore, that's why they will go there. And actually, there is a kind of front heat seat and rear heat seat that is not emitting the beacon. Therefore, there is another way, not really depending on the beacon signal, but anyway, the instrument module has the Ryugu's sample. Therefore, anyway, such kind of measures is necessary too.
じゃあ、ウーメラでの回収作業を今説明しました。
So we have explained the collection activity at Umera, and I heard there's movies showing the preparatory work at Umera. I want to show you.
こんな状況ですね。大川さん、昔のことを思い出します。
And this is Mr. Okawa. I think you remember when you were there. Yes, I remember the desert. Also, this is the desert. We have some low trees and some grass, and it's sometimes rain and plants. And you can see the earth, and there are many animals, some animals. What? Sheep or something? This is DFS. And this is rotating. And so that it can identify the direction where they can receive the strongest signal. This is drone.
これはあれですね、DFS で
Yeah, this is a backup just in case when DFS cannot identify it. And also this is used for searching for the front and back side heat shield.
ドローンといっても我々の
Yeah, we call this drone, but this is not. This is different from the drone we are familiar with. This drone is like an airplane shape, and when we make programming, they can fly so that they can capture the images without any omission. They continue capturing from the sky, and the AI analyzes and try to extract the capsule location. Now we will move on to Mr. Hosoda. Mr. Hosoda, can you hear me? Yeah, to studio. Yeah, we have Mr. Tsuda with me. So I would like to make an interview to Mr. Tsuda. Mr. Tsuda, how do you feel? Yeah, I'm really pleased. At the control room, we do not receive any wave, so we are now relieved and just listening to the report. That means waves are caught, received. That means the capsule have already landed, and I hope the helicopter will fly soon. Yeah, this is a beautiful story. We are also moved and inspired. So we continue working. The next one is Mr. Yoshihara, the capsule collection team. So Mr. Yoshihara, the capsule collection team. It's a perfect operation. Congratulations. So far. Thank you. The capsule is its operation of the last day. So we have been looking forward to today. We are happy because every other member did a very good job, but we are under pressure because we also have to do that. But finally, capsule worked at the end. But still, we have not found sample yet, so we need to continue monitoring. Thank you. So we return the control to the studio again.
はい、ありがとうございます。それでは、
Thank you.
ここで拡張ミッションの説
And
明を
now I would like to explain about the extended mission.
スライドをお願いします。拡張ミッション
Can you show us the slide about the extended missions?
すでに、TCM5 で
So we have completed the TCM5. So this was we were successful
これ細田さんの例え
leaving the Earth sphere. So according to Mr. Hosoda, it's like the kid of elementary school just go home, just throwing away the land back and going for another asteroid. So what asteroid is it going to? The next destination is 1998 KY26. It was not named yet. And it will arrive 11 years later. The size is very small, 30 meters, and it's spinning. It takes only 10 minutes for one rotation, and radius 1.23, and the orbit period 1.37 years. And we have started the extended mission, and we will experience swing by and fly by from another asteroid. And the rendezvous of the target is 2031, so 11 years later from now. So I said this is small. So Ryugu is big as this, 900 meters compared to this. This is only 30 meters like this. So when we compare it with Hayabusa2, it's like 6 meters, so compared to 30 meters. So this is a comparison with Hayabusa2. You can see this is very compact and it's spinning at a very high speed. And this is a relation between the diameter and the spinning period. The smaller the diameter is, the spinning period is also small, and this is a long scale. And the diameter is less than 200. And the rotation period is 2 hours in this area. Actually, we have not explored. Then this is one of the unexplored asteroids.
And as for the significance of the extension mission, actually, we have to increase, or you have to make the progress of the the long voyage technology, and also this is very high-speed spinning asteroid, small asteroid. It means that centrifugal power or force is very strong, and actually target marker can't stay on the surface of such kind of asteroid. And for instance, this is aggravated or just, the one rock. We are not really sure and how to handle this kind of small asteroid. And also, it has to be a great contribution for the planetary defense. This is, the significance of the extended mission. Planetary defense, actually, this means that if this kind of asteroid or meteorite crash to the Earth, it's quite dangerous. That's why we have to prepare for that. Yes, that's right. same as Ryugu, and this one, KY26, it is moving very close to the Earth, and if the timing is unfortunate, it may crash to the Earth. And actually, as for the small asteroids, there are so many celestial bodies in large numbers. Therefore, we have to know very well that is a great contribution for the planetary defense. And if we name this asteroid, maybe the person who found this asteroid has a right to name it. And actually, there is a kind of a group who like to find the stars, and it was found in 1998. And therefore, as for the name, maybe we should discuss with that space watch who found this star. Well, actually, there are some reasons. That's why we cannot name it. So maybe some days later, maybe we can know. It seems if there is some more time, I'd like to talk about our campaign. Please go back to the slide. Don't you remember that you wrote your name? Actually, here is a kind of mirroring campaign too. Why don't we see the little prince of the star? Actually, I was forgetting to write my name, but maybe probably the people who took part in this campaign should remember your name. Your name and the message were actually written on the memory of the target marker 7. And if you go to this page and if you enter your name, and you can know that your name is written here. And what is this shape then? Actually, this is the shape of the target marker. If two ones are kind of overlapped, actually this kind of outer seat, your names are written, and also capsule is equipped with memory, and in that memory, it has the same names, and that memory has come back to the Earth. And if you remember that you applied for it, please access to this site. Amongst the support message, actually some message said that it really has come back. There are so many such kind of messages. Yeah, it has really come back. Regarding the target marker, absolutely, the target marker landed on Ryugu, and some of them are staying on Ryugu, but the messages are in the capsule, and that came back with the capsule and came back to the Earth. That's right? Yes, that's right. It has come back. But however, there is one remaining, as you say. Yes, that's right. That's for the target marker. Two were left on the surface of the Ryugu, and two are, on the orbit of, the rotating around Ryugu, and another one is still attached on the Hayabusa. Therefore, anyway, the remaining one will travel with Hayabusa2 for 11 years, and it will go to the KY26. Anyway, what to do is, the later I would like to discuss. Anyway, with curving our name one by one, the people who enter this project should be kind of, feeling one of the family members of Hayabusa. And also, there are so many support messages that, the Hayabusa is something like, the family member of those peoples. Maybe we started this campaign about 6 or 7 years before, and in those now I remember how I was feeling in those days. Regarding this kind of campaign, do you do this campaign? Yeah, not that just, but actually even at NASA, we do this kind of campaign. Therefore, anyway, wherever we go in the solar system, actually we should do it. And actually, this is not just somebody else's issue, but it's my own issues.
And this is from the control room. The explorer will soon be ready for the next operation. That means it will go through the shade and they will go back to the normal operation. So after the launch, 1 year after the launch, the explorer did the swing by of the Earth, and friction occurs and aerodynamic heating occurs. So the speed is decreased and to almost the same as the speed of the sound. It's around 340, and impact wave. It gets motion gets unstable, and it is continued this posture. And when the speed goes down to 0.1, then heat shield is separated at this point, and it's separated into 3 parts, as I explained before. At the center portion, this is an instrument module, including container, parachute goes to collect the capsule. So that means we have backup, but we do not have to use backup method. It's likely. But I think still the backup members still continue measurement. So shall we see the replay movie? Now from the right the missions. So we have
Hayabusa2 は11年をかける新しい旅に出発します。
Hayabusa2 will now go on new journey. The target is
we do like to start the initial analysis. That is a kind of procedures. And are there any movements in Australia? First, hello, this is Fujimoto in Australia.
We will do a new operation status and new issues. And since this is a long period operation, I think we'll be able to establish the energy saving operation method. And utilizing this cruise period, Hayabusa2 will do a scientific observation. One of them is the observation while changing the distance of the zodiacal light, so we can identify the distribution of dust. And also we will observe the transit phenomenon. And the first highlight is a high-speed flyby to asteroid 2001, CC21. A flyby is one chance, and we cannot use a telescope camera, but we would like to use our experience and do the capture. It's really excited. Next, we will do 2 Earth swing by. And we hope that we can see Hayabusa2 once again from the Earth.
そして
And
2031年いよいよ
2031,
目標天体に
we
到着
will arrive the target body.
相手が小さいので
Since the asteroid is small, we need a more higher precision for its
今度の
guidance.
小惑星は
So what a new asteroid will look like, I'm really looking forward to that.
10本余りで一周
So it's a very high speed spinning
なぜこのような
body.
小惑星がバラバラにならない
Why this is so fast, but this would not get the
Anyway, we'd like to see it. The large meteorites coming falling to the Earth is this kind of, the asteroid. Therefore, for the predator defense, observing or researching about this kind of meteorite is very important for the planetary defense. And still, Hayabusa2 has a target marker, and therefore, it should be quite difficult. But anyway, would you like Hayabusa2 to challenge the touchdown? Now we are very much excited with a new voyage, and this is a new challenge, new travel, and we will fire the last bullet. Hayabusa2 is immortal. Let's go once again. Let's go to the next generation voyage, and let's challenge the unknown asteroid. Well, actually, that we could see the extended missions video. And about this one, let me introduce some messages of the support. I'm always sharing this project, and I love Hayabusa2. When seeing you who are working alone in the far away in the space, actually, I'm so happy, and thanks to you, friction occurs and aerodynamic heating occurs. So the speed is decreased and to almost the same as the speed of the sound. It's around 340, and impact wave. And it gets motion gets unstable. And it is continued this posture, and when the speed goes down to 0.1, then heat shield is separated at this point, and it's separated into three parts, as I explained before. At the center portion, this is an instrument module, including container, parachute deployed, and it starts descending. And altitude is 10 kilometers. And after parachute deploys, it's affected by wind. So when the parachute deploys, this is beacon antenna. So the beacon transmits a signal, and the ground station receives it. Then it can identify the direction, and helicopter uses this information from this beacon. And in case there is no beacon signal, and there is something on the parachute which reflects the radar beam. The Mari radar emits radar beam, and it reflects, and we can identify the distance. And when the instrument module is landed, and still beacon transmits signal, not continuously but intermittently.
で、あと風で飛ばされないようにこのパラシュート。
And the parachute will be detached after it's landed to avoid the capsule is moving. And this is the time and the altitude of the sequence. And at 228,
もうすぐですね。
and it will be very soon.
下級フェーズ。
So we can see a fireball phase. So the altitude down from 120 to 10 kilometers.